In the last video lesson, we looked at finding the lowest common multiple of polynomials. In this lesson, we want to apply that idea to finding the lowest common multiple of the denominators of our rational expressions. Now, I think in Pearson, you'll often see that called the LCD, or the lowest common denominator. So if we're looking at our denominators, you'll see that they're both polynomials. So we're going to use the same strategies we found for finding the lowest common multiple. The first thing we did was factor each of the polynomials. Now, to find the lowest common multiple, remember what we said. We use all of the factors from our first expression. And when we look at our second expression, we see we already have x plus 4. We don't need another one, but we do need the factor of x plus 2. Why don't you pause your video and find the lowest common multiple of the denominators for question 2. All right, your lowest common multiple. You looked at the first expression and you see two factors are required, x minus 3 and x minus 1. We don't have x minus 2 yet, but we already have the factor of x minus 1. We don't need it again. Now we want to use this idea of finding a lowest common multiple of the denominators to create equivalent expressions. When we create equivalent expressions, the first thing we want to do is factor the denominators. And then we multiply the numerator and the denominator by the missing factors. I should add something to part 1 there. Factor the denominators and find the lowest common denominator. Then we multiply by the missing factors. Here's an example that's partly done. You can see in the first expression that we haven't factored the denominator. 3 is common. We want an equivalent expression, so we have to multiply by what's missing. Do you notice that the y is missing? We don't have y in our first expression. So we're going to need to multiply the numerator and the denominator by y to get our equivalent expression. That means that our equivalent expression here is 7y all over 3y times x minus 5. Let's do one more together here. There's nothing to factor in the first expression in the denominator, but do you see what's missing? Let's see if I can give myself a bit more room here. Oh, no, I surely can't. All right, I'll just rewrite it. I can see that we had a 7 times 11 to give us the 77. We have a to the power of 5 here. That means this was multiplied by a cubed. We also have b squared. That was not in the original denominator. That means that the numerator must also be multiplied by 7a cubed b squared. So our equivalent expression then is negative 28 a cubed b squared. I can see in question 2, you're going to need to factor. Why don't you pause your video, see if you can create the equivalent expression. Do you see, once you've factored the denominator, that you're just missing this factor of y? That means the numerator and the denominator would need to be multiplied by y. So our equivalent expression is negative 4y all over that denominator. In question 3, you're going to need to factor both of those denominators. See if you can figure out what's missing. Pause your video, give it a try. You factored the denominators. We're missing this factor of x plus 2. That means that both the numerator and the denominator will need to be multiplied by x plus 2. Now, if you were asked to leave your answer in factored form here, it would look like this. Remember, the order of your factors doesn't matter. If you had x minus 1 times x plus 2, that's fine. But if it's not asked for factored form, you'd need to open your brackets here. We already have the denominator multiplied out for us before we factored it. So both of these are correct. Just be careful what's being asked for when you're finding an equivalent expression. That takes some practice, but is going to be really important when we look at adding and subtracting rational expressions with different denominators. Now, there is one other topic I wanted to talk about here: the negative of a rational expression. This one is super important, and I see people even in Math 103 and in calculus not understanding this. When there's a negative sign outside of a rational expression, it does not equal the negative of the numerator and the denominator. Think about that. If we have negative 1 times x plus 2 all over negative 1 times x minus 7, what do you know about negative 1 divided by negative 1? It equals positive 1. These would divide out, and we wouldn't have the negative of the expression. So when there is a negative sign outside of a rational expression, it means that the numerator is negative, or it means the denominator is negative. Not both. So that means I could write this as negative x minus 2 all over x minus 7, or I could write it as x plus 2 over negative x plus 7. And in fact, especially in this one with that negative x, I could write this as 7 minus x in the denominator. But I could do that here as well. I could change the order of the negative 2 and the negative x. I could change the order of the negative 7 and the positive x. There are lots of different ways you can write the negative of a rational expression, but the one that you cannot do is the negative of both the numerator and the denominator. I want you to pause your video and find 4 expressions that are equivalent to the negative of 3 minus x over x plus 5. So maybe you first found the negative of the numerator. That gave us negative 3 plus x all over x plus 5. And of course, we could change the order in the numerator as x minus 3 over x plus 5. You could have even written this as x minus 3 over 5 plus x. All of those are equivalent to this one. But the second possibility is that you found the negative of the denominator. Three minus x over minus x minus 5. We could have changed the order in the denominator. We could have changed the order in the numerator. You can see there are more than 4 ways to write it, but you cannot find the negative of both the numerator and the denominator. Please be careful of this going forward.